This is June 09, question 6. First question is all about the equivalence of resistor networks. So you've got a 12 volt battery of EMF 12 volts, no internal resistance, so we can forget about that. It's connected to a resistor network as shown. Show clearly that the resistance of a single equivalent resistor that could replace the 4 resistors across points A to B is 31 ohms. So it's really just this part to this part. So if I just do the top circuit first of all, the one on the left, you've got 20 ohms and 60 ohms. So I'm going to do this with the product over the sum. And so R in parallel for this bit, or in fact I'll just say, yeah, R parallel is 20 by 60 over 20 plus 60. And that comes out as a value of 15. The other part of the circuit has got a 24 ohm resistor in the top and a 48 ohm resistor on the bottom. And so the total parallel bit is 24 times 48 over 24 plus 48. And that comes out as having a value of 16. And so the total resistance, you just add them up because they're in series with each other, is 15 plus 16, which is 31 ohms, which is what you're trying to prove. So lay it out well so that you can see each bit very easily. Especially when it says show clearly, you need to really lay it out so that it's very, very obvious to an examiner. It says the current delivered by the battery is 300 milliamps. Calculate the total circuit resistance. So if you just use R is equal to V over I, that's 12, total EMF of 12, and the total current is 300 milliamps. You need to be careful with that, is 0.3 amps. So the total resistance is 40. And then it says, hence find the value of the resistor R. So the resistor R is here. We already know there's 31 ohms across this, and the whole thing is 40. So R is going to be 40, take away 31. So R is equal to 40 minus 31, which gives you an answer of 9 ohms. Last part of the question says, find the current in the 48 ohm resistor. So if you have a wee look at this again, we now know the current flowing through the whole thing. If we can find the total voltage across the whole thing here, then we can apply that total voltage to this resistor on its own and find the current through it. So what we're going to do first of all is find the total voltage across that. We know there's a current of 300 milliamps across it, and we know that it's got a resistance of 16. So the voltage across the whole part, what will I call that? I'll just draw the wee circuit here, the 24 and the 48. Okay, so voltage is equal to I times R. We know its total resistance is, from our initial calculation in part 1, is 16, and it's got a current of 300 milliamps or 0.3 amps. And so that is 4.8 volts. And then all we have to do is I is V over R, and we're using that because the voltage across one is the same as the voltage across the other, and the voltage across the whole combination is 4.8. And we're going to divide that by 48. Yeah, it's a 48 ohm resistor. And that's obviously going to give you 0.1 amps there. Now, there is a second way of doing it. They've left their answer in milliamps, so that's 100. The other way of doing it is just to do a ratio. So you know the current going in is 300 milliamps. And the ratio of the two resistors, 24 to 48. Now you have to be careful because the bigger resistor is going to get less current, so that's where you need to be careful. The ratio of 24 to 48 is obviously 1 to 2, but if you remember, because that's a bigger resistor, this here is going to get the two-thirds worth of current through it, and this one here is only going to get 1/3. So 1/3 of 300 is equal to 100 milliamps. So that's just an alternative way of doing that. You didn't have to do the rest of the question because it's now not on the specification anymore.